Alright guys, welcome back. We're going to be solving another question in today's video, and we have problem 70 from the second chapter of the Meriam textbook. And in this question we have the overhead view of a portion of an exercise machine, and we know the tension in the cable is T, which is 780 newtons, and we need to determine the equivalent force coupled system at point B in the A part of the question and point O in the second part of the question, and we need to express the answers in vector format. So we are dealing with force coupled system. We need two things: force and a moment or a couple. So for finding the force, we have our x and y in here. So if you look at these two lines, these two are actually parallel to each other. Each of them are perpendicular to here. And if we draw this vertical line in here, this angle here would be 20 degrees, meaning this angle is here is 20 degrees too. Since we have 40 for the whole angle, so each of them will be 20 degrees. So now that we have the 20 degrees with vertical point, it's piece of cake to find the x and y component. So as we can see, x component will be to the right, so this will be our x component and this will be our y. So the x component is positive since it's to the right, so t times sine of 20 degrees, that would be our x component or I. And since the vertical component is downward, we have a negative sign, and it will be t cosine of 20 degrees. And j, again, keep in mind that we have to have everything in vector format. So if we calculate this, we already know that t is 780. From the first one we get 266.8, and we get minus 733 J, and the unit will be Newton. That's our force, so the force is done. So for A part and B part, we have the same force, and that's pretty much the force that we have, since that's the only force that we have in this figure. So now we have to figure out the moment, and what we're going to do for the moment is we're going to take a different approach. So since this angle is 90 degrees and we know this part is 40 degrees, this angle right here is 50 in order to make that right angle. So 50 plus 40, it's going to give us the 90 degrees. But if we look at this, if we want to dissolve it in, I'm going to show it in red, then we can see it better. Dissolve it into this component and this component, our t. The reason I'm doing is that we can cancel out the moment of this component because it passes through the point B, so no moment from that one. We basically have the moment of perpendicular component to AB, and that's probably the fastest way to find the moment in here. Obviously we can go with the t that we found in the previous step, x and y component, but we have to figure out the distance or the perpendicular distance of the line of action to point B in order to find the answer. But this is the easiest way, and if we want to find the perpendicular component or this one, we can see that that would be t. So we're trying to find a moment about point B, counterclockwise positive as always. We have t sine of 50 degrees, and the distance would be what we have from A to B, which is 381 minus 83 over 1000 in order to get it in meters. And what I did, basically I subtract this distance by this one in order to get what we have from here to here, and this will be 298, and if we calculate the moment, we're gonna get 178.1 Newton meter, and the direction, as we can see, is counterclockwise. So that's the A part of the question. Again, for each of these parts we need to report both t and moments, and that's going to be our force coupled system. So since we are in 2D and we are asked to express the answers in vector format, so obviously our moment will be in z direction, and since it's counterclockwise, a positive, so we're just going to put a k in here. That's going to give us a moment in a vector format, and our t, we found it in the previous step. Again, we need to write it down, 266.ai minus 7. So that's the answer for the A part of the question. In the B part of the question, we have to find the moment about point O. Alright, so if we want to show I'm just going to clean up the figure. So if we want to show the force coupled system at point B, basically what we have at B is, this is our force T, and we found our moment MB, which was 178.1 Newton meter, and this is our force coupled system. If we are asked to show it, this is how we show the force coupled system. So this is the T is our force, and we have the moment. So the second part is pretty easy. We have to do the same thing. I'm gonna show the second part with different color, maybe a light blue. So basically we have the same force T obviously in here too, and we have to find that moment about point O, which which we're going to show it in this way. And if we want to do that, we have to find the moment about point O. We have two things. So first of all, again, we know this angle right here is, so as we talked about, this angle here is 40 degrees, which is what we had in here, and this angle here would be 50 degrees. And for finding the moment about point O, basically we have, I'm just going to clean this up, I'm going to show it at the end. So for finding the moment about point O, we have the moment of t plus what we have at MB. So our MB is 178.1 plus the moment of the t about point O, which we can again dissolve it into these two components. And as we talked about, the horizontal component won't make any moment since it passes through the O, and we are left off with the moment of the y component, which is t sine of theta. So t sine of theta, and the distance that we have is the distance from O to B, which is what we have in here, 127 millimeter. So times 127 millimeter, we're going to divide it by 1000 to get it in meter, and the theta in here would be 50 degrees. Actually, I don't know why I put theta in here, so it will be 50 degrees, and this is going to give us the moment about point A, and if we calculate this, we'll get 271.16 Newton meter, and the moment would be counterclockwise. And we have the same thing, we want to show it in vector format. The moment will be in K direction, and since it's counterclockwise, it will be positive. And the t that we have, again, same t as previous part, 0.8I minus 733J Newton, and that's going to give us the answer for the B part. Again, if we want to show it in here, I'm just going to clean up. If we want to show our force coupled system at point O, basically we have the same force T, and the moment this time would be our MO, which was 271.16 Newton meter. So yeah, that's pretty much everything for this one. Hope you guys find it helpful. Let me know if there is anything unclear. Feel free to drop it in a comment. I'd happy to answer all the questions. And please make sure to subscribe to the channel, like and comment. It's going to help me to reach out to more students. And you guys take care. I'll see you in the next one. Have a good one.